After weeks of punishing heat across the south, relief is finally arriving. That should be the good news story. It isn't. Because what's actually moving in to replace this heat dome isn't a gentle return to normal. It's a violent clash between retreating heat and incoming cool air, capable of unleashing severe storms across more than a dozen states. And hundreds of miles away, in an entirely different part of the country, a brand new heat dome is already building, one that's about to make an already dangerous drought considerably worse. The heat wave is ending. What comes next might genuinely be more dangerous than the heat itself. So what's actually replacing this heat dome? Why does its breakdown create a severe weather threat instead of simple relief? And why are scientists watching the next several days with more concern than the heat wave that's finally fading? A summer that never really stopped. To understand why this transition matters, you need the full picture of what this summer has already delivered. This is the third major heat dome to grip the country since late June. The first hit the eastern United States and eastern Canada. From June 28th through July 5th, peaking at 106 degrees in Atlantic City on July 4th itself, tying its all-time temperature record and coinciding with Independence Day celebrations that had to be scaled back or canceled outright in cities including Washington, D.C. and Philadelphia. The second built over the western half of the continent, setting Billings, Montana to an all-time record of 111 degrees and pushing Salt Lake City to its hottest temperature in more than 152 years of recorded weather history. Parts of southern Nevada and California saw heat indexes climb past 118 degrees, hot enough that emergency daytime cooling stations had to open across the region. As of early August, this year's heat had already been linked to at least 70 confirmed deaths, a toll researchers have cautioned is likely an undercount, since heat deaths are notoriously difficult to fully document in real time, often only recognized well after the fact through medical examiner reviews. Then came this third dome, settling over the Gulf Coast and the South for days on end, with overnight lows stuck in the 80s across major cities, offering almost no physical recovery before the next scorching day began. Florida just recorded its fourth warmest start to meteorological summer on record. South Carolina posted its warmest March through July stretch in its entire climate record. Cities like Little Rock, Arkansas saw daytime highs run 10 degrees above normal for days in a row, with heat indices across the region regularly climbing toward 110 to 115 degrees. 3 heat domes, one summer. And now as this third one finally begins to weaken, the transition itself is turning into its own hazard. Why breaking a heat dome isn't the same as ending danger? Here's the mechanism worth understanding, because it explains exactly why this transition is dangerous rather than simply comfortable. A heat dome is essentially a massive ridge of high pressure that traps hot air in place, acting like a lid clamped down over the atmosphere. As long as that ridge holds firm, thunderstorms struggle to form because the sinking air inside a strong ridge actively suppresses the upward motion storms need to develop. That's part of why heat domes tend to bring long, dry, brutally hot stretches, rather than the pop-up thunderstorms a normal summer produces, sometimes going a week or more without a single drop of meaningful rain across an entire region. But when that ridge finally weakens, whatever instability had been bottled up underneath it doesn't just quietly dissipate. It gets released, often violently, especially where the retreating hot, humid air collides directly with cooler air pushing in from the north. Think of it like a pressure valve that's been held shut for days, finally giving way all at once, rather, then easing open gradually. That collision zone is exactly where severe thunderstorms tend to explode. Forecasters are describing exactly this kind of pattern flip developing across the southeast right now, as a ripple in the jet stream moves through and disrupts the ridge that's been sitting in place for days. More than 30 million people across at least 16 states now face the risk of severe thunderstorms, with damaging winds and large hail as the primary hazards. 2 specific danger zones have emerged, one stretching across the plains, another concentrated over the Tennessee Valley and the Carolinas. And in a detail that should sound familiar by now, the same areas facing that severe weather risk largely overlap with an elevated flash flood threat, the same dangerous combination that produced Indiana's catastrophic, record-breaking flood earlier this month. What living through the transition actually feels like, picture what this actually looks like on the ground for someone in, say, Nashville or Charlotte over the next few days. Monday might bring the tail end of oppressive, record-challenging heat. Air so thick and still it barely moves. By Tuesday or Wednesday, the sky darkens fast. Wind picks up out of nowhere, and what started as relief from the heat turns into a warning siren, damaging straight-line winds, hail large enough to dent a car, and a flash flood warning stacked directly on top of the severe thunderstorm warning already in effect. That whiplash, from oppressive stillness to sudden violence, is precisely what makes this transition period more dangerous than either the heat or the storms would be entirely on their own. People conditioned by weeks of heat to expect nothing but more heat aren't. Always mentally prepared for a sudden, fast-moving, severe weather threat, arriving in the same forecast cycle that finally promised relief. Emergency managers describe this exact dynamic as one of the trickier public communication challenges tied to a pattern flip like this one, convincing people to switch their mental framework from heat safety to storm safety within the span of a single day. The ground is still primed for disaster. That overlap between severe storms and flash flooding isn't a coincidence, and it connects directly to something we've covered before in this series. Weeks of intense heat leave soil compacted and hardened, dramatically reducing how much rainfall it can actually absorb, the same way a dried-out sponge left in the sun for weeks initially beads water on its surface rather than soaking it in. When a burst of heavy rain finally arrives after an extended dry, hot stretch, it doesn't soak in the way it normally would. It runs off almost immediately, overwhelming drainage systems and waterways far faster than the same rainfall total would under normal conditions. That's exactly the setup now developing across parts of the southeast and the Tennessee Valley as this heat dome finally breaks. Weeks of trapped heat and minimal rainfall have primed the ground. Now a wave of potentially severe, potentially flash flood-producing storms is arriving right on top of it, in some of the same states that have spent the summer watching rain gauges sit stubbornly empty. The relief comes with a catch, and the catch has a catch. Here's where this story gets genuinely worse instead of resolving neatly. While the Southeast finally sees its brutal heat break, at least temporarily, meteorologists are already tracking the next heat dome, this one building across the western United States. Intense heat is forecast to grip much of the interior west through the back half of this week, suppressing the monsoon thunderstorm activity that region actually needs to ease its own worsening drought. Falling river and reservoir levels across the west are already a serious concern, and this new ridge is expected to accelerate that decline further, driving high evaporation rates precisely when the region can least afford them. Texas alone already has burn bans active across 144 of its 254 counties, a direct consequence of the extended dry, hot stretch this same broader pattern has produced across the southern plains this summer. In other words, the same broader atmospheric pattern responsible for ending one dangerous heat dome in the east is simultaneously constructing a new one in the west, suppressing exactly the rainfall that region depends on to keep its drought and wildfire risk in check. One area trades extreme heat for severe storms and flash flooding. Another trades relief from earlier heat for renewed, drought-intensifying heat building right back in. This isn't two unrelated weather stories happening to land in the same week. It's the same reorganizing jet stream, the one meteorologists have been tracking all summer as it splits, wavers, and locks weather systems in place for days at a time, simply redistributing where the danger sits, rather than actually resolving it anywhere. Why scientists say this is the expected shape of modern summers. It would be one thing if 3 heat domes producing this kind of chained, overlapping danger in a single summer were unusual. Increasingly, meteorologists say it isn't. A heat dome forming, breaking down into severe weather and then reforming somewhere else entirely, is becoming what climate researchers describe as the increasingly expected shape of American summers, rather than a rare, unlucky sequence of events. Rising carbon dioxide levels from fossil fuel emissions make it measurably more likely that heat waves arrive more frequently, hit harder, carry higher humidity, and produce higher overnight temperatures, according to climate researchers tracking these patterns. 1. Climate scientists put it bluntly earlier this summer. This is exactly what the climate models built back in the 1990s said we should be experiencing right now: more frequent and more severe heat waves, bigger temperature anomalies, more humidity, higher overnight lows. That last detail, overnight temperatures staying elevated, matters enormously because it's specifically what prevents the human body from recovering between one dangerous day and the next, allowing heat stress to accumulate rather than reset. Layered underneath all of this is the broader pattern this series has tracked for weeks now, a rapidly strengthening super El Niño reorganizing the jet stream itself, splitting it into a configuration that's locking weather systems in place for unusually long stretches, whether that means a heat dome refusing to budge for days, or a storm system training repeatedly over the same corridor until it produces a historic flood. Europe has been living through an almost identical version of this same pattern in parallel, with the 5th heat dome of the season pushing temperatures past 40 degrees Celsius across Spain, France, and Central Europe. In mid-August, driven by a similar blocking high-pressure setup. This isn't a uniquely American phenomenon this summer. It's a global signature of the same broader atmospheric reorganization playing out on multiple continents at once. Why this keeps catching people off guard. There's a psychological piece worth naming here too, because it's part of why this specific kind of transition tends to catch communities off guard more than a single isolated disaster does. Heat advisories and severe thunderstorm warnings are issued by the same agency, often within days or even hours of each other, but they trigger completely different mental checklists for most people. Heat safety means staying indoors, hydrating, checking on vulnerable neighbors. Severe storm safety means watching the sky, knowing where the nearest sturdy shelter is, being ready to move immediately if a warning is issued. Switching between those two mindsets fast enough to stay genuinely safe is harder than it sounds, especially after weeks of a single monotonous hazard that trains people to expect more of the same rather than something entirely different arriving without much notice. What actually happens next? So here's what genuinely matters going forward beyond any single day's forecast. Watch the Southeast and Tennessee Valley over the next several days specifically, since that's where the sharpest collision between retreating heat and incoming cooler air is expected to produce the most significant severe weather and flash flood risk, in exactly the kind of soil conditions that turn heavy rain into dangerous flooding fastest. Watch the interior West simultaneously, since the new heat dome building there isn't just uncomfortable, it's actively worsening an already serious drought and setting up worse wildfire conditions heading into what's traditionally one of the most dangerous stretches of fire season, with burn bans already in place across more than half of Texas's counties before this new ridge has even fully built in. And watch how quickly, or how slowly, this pattern of one hazard directly replacing another continues through the rest of the season, since that chain reaction, not any single heat dome or storm system in isolation, is what's actually driving the elevated concern among the meteorologists tracking it. The heat wave gripping the South is genuinely ending. That part of the headline is true. What isn't true is the assumption that its ending means the danger has passed. It's simply changing shape, moving from one kind of hazard into another in one region while quietly rebuilding in a completely different one. That's the part of this story that isn't really about the weather ending at all. It's about a pattern that keeps finding new ways to stay dangerous, one collision, one reforming ridge at a time.